All right. Greetings, YouTube. Beautiful mind here. The following question comes in from college algebra. Um, this says that fencing with the length of 540 meters surrounds two identical playing fields with a common side. The fields can be side by side and separated by a fence as shown in the figure. Find the dimensions and the maximum area of each field. Okay. So I'm just gonna kind of draw my own basic shape or draw out this in on my own just to have something I can edit. And then we have something like this. Okay. So we essentially have something like this. Let's see. It says the fencing with lengths of 540 meters surrounds two identical playing fields with a common side. The fields can be, let me see. Okay, so the 540 refers to what? Okay, here, let's do this. Let's let this side over here be our x, and let's let the entire top, so be our y, going from here to here. All right. So then they gave us 540 meters, right? That's going to refer to our perimeter. So, or the entire, all of the fencing, right? So if we want to capture that 540 in an equation, basically add up all the sides, right? So we have three of these guys. 1, 2, 3, right? So that would be x plus x plus x gives us 3x. So we can say 3x plus 2y is going to equal 540, right? But then, let's see. Common side, the fields can be side by side. Find the dimensions and maximum area of each field. So then if we want the area of each field, the basic shape of each field is a rectangle. So the area of a rectangle is length times width, but in this case, it's going to be, yeah, it should be x times y over 2, right? Okay. Okay. So let's see, can we get the area in terms of x? We have essentially two equations and we want to maximize the area. So what I'm going to do, let's solve for y from the first equation and then take that y and plug it into the second equation. Okay. So then if we have, let me get a copy again and let's make this a little bit thicker. So then if we have 3x plus 2y equals 540, if we're going to solve for y, we can subtract 3x on both sides. We get 2y equals 540 minus 3x. Divide both sides by 2. Think about it. Yeah, let's keep going. So then we get y equals, if we divide both sides by 2, let me see, there's 2, 14 is 7, 270 minus 3 halves x. I just divided each of those terms by 2, right? So we get this expression for y. So then what I'm going to do is take this expression and plug it into my area formula. So then we should be able to get area in terms of x alone is going to be x times this y, which is this 270 minus 3 halves x all over 2, right? So we have a fraction within a fraction. We can use, let's use keep, change, flip to simplify this fraction down some. So this is going to be equal to x times, so dividing by 2 is the same as multiplying by a half. So we can multiply each term in the top by a half. Let's see, half of 2 is 1, so 3, 5. And then the 3 halves turns into 3/4 x. Okay, that should be okay. Okay, so then if we distribute the x, then we get, looks like we get negative 3/4 x squared plus 135x. Okay. So now we have an expression for the area in terms of x alone, right? So now the question asks us to maximize the area, right? Notice that the highest degree is a 2, so this should be the graph of a quadratic. This chapter that we've been working on, this chapter 2 from this text, is all concerning is it? Maybe it's not the whole chapter, but at least this section was concerning quadratics, right? So what that means is that the basic shape here is going to be a U-shaped graph. Like if we were to look at the graph, it's going to be a U-shaped graph. And notice that the leading coefficient is negative. So that means the parabola is going to open down. Because the parabola opens downward, we can have a maximum value, right? Okay, that's going to occur at the vertex of the parabola. So we can actually just jump straight to the vertex, right? This is the vertex formula. The vertex formula, let me see. So for the vertex of the parabola, we want the x-coordinate of the vertex, which is our h, is going to be negative b over 2a, right? So then this is going to be negative 135 over 2 times negative 3/4, right? Okay, so double negative is positive. Let's see. We can do, so this 2 turns this 4 into a 2. Okay, and then again, double negative becomes positive. So then a fraction divided by a fraction, we can do keep, change, flip. So then this is going to become 135 times 2/3. Right? Let me see. That's what 4 and 5 is 9. So that is divisible by 3. Okay. So then that would be a 4, 15. So 45. Okay. Times 2 because it's 90. Okay. So our claim is that the maximum is going to occur, the max area occurs when x is 90, and then the max area, which is going to be our y value at the vertex, which is going to be k, all we do is do f of h, whatever answer we just found, right? So then that's going to be f of 90, right? And I think I'm going to just use my calculator for that part. Let's go here, like this, here. Come on. Okay. So here. So then what I'm going to do in my upper left hand corner, I'm going to click on y equals, and then we have this negative 3 by 4 x squared plus 135x. Okay. I'm going to quit. Then I'm going to call on that function I just typed in. So to the left of the clear button, it says variables. I'm going to go to the right to go to y variables, number 1. And I'm going to call the function I just put in as number 1. So then when x is 90, we want to see what's the corresponding y. Square meters, I guess so. Okay. So our claim is that the max area should be, it looks like it says 6,075 meters, right? Okay, let's go back and put this in context. Meter squared. Okay. So now, our claim is that x is 90 meters. Let me think about it. 9 times 3, 270 feet. Okay, I guess so. That could be a reasonable. Oh no. Come on. Okay. And then, so if x is 90, oops, then we can use this guy here to find our y. Let's copy, paste. So then our y should be 270 minus 3/2 times 90. Let's see, 45 times 3. So 90 plus 45 is 135. If that were 40, 70 plus 6 is 130. It's 135. Let me see. I'm just going to use my calculator again just to be sure. So then I'm going to do 270 minus 3/2 times 90. I got 135. Okay, cool beans. So then if y is 135, but it says find the dimensions and maximum area of each field. Gotta do y divided by 2? Okay. So if that's our y, then if we divide that by 2, so it looks like the dimensions of each field will be 90 by 67.5. Let's write it a little differently. 90 by 67.5 with a maximum area and again the units here are meters. We got that 6075 meters squared. Okay. So the best we can do to kind of check this is just think about it like we have to just think about it in the context of the question. All right. That's about the best we can do to check something like this. Because if we set something up wrong or interpreted something wrong, you know. Now on Pearson, you know, we can submit it and it'll give us feedback. But yeah, okay. And so I'm going to end the video and I'm just going to go back to Pearson and check it there. But on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.